Okay, here's another one that said solve the system by graphing. So I'll start with the first equation, 4x equals y plus 5. And if we make our little chart and we say, okay, what if x is 0? So we'll come up over here and we'll put 0 in for x. And I just chose 0 because I looked at the problem and I thought, what's an easy number to use? It's not, I mean, you can use any number in infinity. Don't stress over what number to use. But I knew if I put 0 here, it might keep it whole numbers when I'm solving it, and I'll explain how to avoid fractions in just a minute. But so here we have, this becomes then 0 equals y plus 5. And I want to solve for y because I don't know what y is. I decided that x was 0, so I want to know what the match to it is, and you have to do the math to find out. So to get y alone, we're going to subtract 5 from both sides because this is normal solving equations. So now we have negative 5 is equal to y. So when x is 0, y is negative 5. And then I can say, well, what if, let's see, what if, let's say, what if x is, I don't know, I'm trying to think of something that might work out pretty easily. What if y is 3? And I'll tell you why I chose 3, because I'm looking at 3 plus 5. That's a multiple of 8, or multiple of 4. 4 can divide into 8. So I thought, well, if I put 3 plus 5 in there, how can I divide with 4 and come up with something that's not a fraction? So let's see, 4x equals 3 plus 5. And then, so 4x equals 8. And then to get x alone, divide by 4 on both sides, and I get 2. So when y is a 3, x is a 2. So we have our two sets of coordinates. So we can come over here, and at 0 on the x, like left and right, 0 here, and then negative 5, 1, 2, 3, 4, right down here is the y-intercept, basically, is what that is. And then I'm going to kind of eyeball it. 1, 2, 1, 2, 3. Here's the 2 and 3. So this is, and I'm so bad at drawing these lines freehand, but this is the first line. Okay. Now, we'll go to the other equation. 8x minus 5 equals 2y. And we can, again, start off with solving some equations. So when I look at this, excuse me, if I said, what if y is 0? Let's see what would happen. So we'd have 8x minus 5 equals 2 times 0. Let's see, 8x minus 5 equals 0. And then I want to get x alone, so I'm going to add 5 to both sides and divide by 8. Ooh, that's ugly, isn't it? Getting a fraction. It's a true answer. It's just graphing fractions we can't do. So I'm going to do something different with this equation just to make it a little easier for myself. So let me think about this a second. Instead of using it as 8x minus 5 equals 2y and using this chart, I am going to work to get y alone so that it's in y equals mx plus b format. It makes it a little bit easier to graph it. So to get y alone, I have to divide everything by 2. So this is going to be 8x divided by 2, which is 4x, and then negative 5 divided by 2. Okay, and then this divided by 2 gives me y. And so sometimes if you flip it around the other way, you can see that y equals mx plus b format, like here, like that. Okay? So now we know, in this case, that the y-intercept is at 0 and negative 5/2, which is actually at what we call negative 2.5. And if they've given you a problem like this, then on your graph, it will have been broken up into half marks. So you might see like a mark here and then a 1. and then a mark here, and then a 2 kind of thing. So it is showing half, and you have to look closely at the graph. You might have to magnify it. Actually, the one I'm looking at from this problem, yes, that is how the graph was set up. They did allow for fractions on this particular graph. So we know that the first point is at 0 and negative 2.5. So it would be down here. And then if we put, go back to this equation, and we put 0 in for y, or we can even use the slope. The slope is right here, so 4 over 1 tells us to go up 4 on the y and up 1 on the x. So a negative 2.5 plus 4, if you put that in your calculator, negative 2.5 plus 4, or 4 minus 2.5, would give you 1.5, which would be 3/2. Positive 3/2, or what you could call 1 and 1/2. And then add 1 to the x. So your next spot is at 1 on the x and a positive 1.5 on the y. So you go over 1 on the x. I want to check and see if because I didn't create this to be up to 3. So let's see, half, 1, half, 2, half, 3. Okay, so over 1 and up 1.5 would be the next spot right there. So then when we draw the line, and if it was by hand better, we would see where they actually cross. I'm not really sure because I'm doing it by hand, but you'd have to put it on the graph to see what is the location somewhere up in here where these kind of crossed. And it's somewhere in this range. I'm not real sure. Let me see if it'll let me check it on here. Check. Okay, I know. Check. I know. Check again. Okay. Oh, okay. That's why it was looking kind of odd to me. If I'd drawn it with a ruler, I would have seen. Okay, so this one, the lines are parallel. They never cross each other. And so they would have no solution because and we could have seen it, like if you're going to learn in the next 2 sections another way to do these to kind of check it. But one thing you learned back when you were doing regular graphing is that parallel lines have same slope. So you know how we got this equation where it said y equals mx plus b, so the slope is 4? Well, if we look up here at this equation, if we had taken this and gotten y alone, so we subtract 5 from both sides, it would have said 4x minus 5 equals y, or you could flip that around and say y equals 4x minus 5. Notice this slope is the same as this slope. If equations have the same slope, they have to be parallel lines.